Hello. Hi, everyone. So we're going to go ahead and get started. It is our introduction to Virtual Kubelet. Thanks for coming out. I have one question. How many of you guys have actually tried Virtual Kubelet or used it? Nice.
Perfect.
OK, great. So for the majority of you, this will be really helpful. And even for the people that have used it before, we have some cool things to show off. So maybe the next slide. Oh, I can do it.
Yeah.
OK, so my name is Ria Bhatia. I'm a program manager at Microsoft. That's my Twitter handle. I am currently a core maintainer of Virtual Kubelet. So we've done some governance things in the next 1.0. So we have a difference between provider maintainers and then core maintainers. I'm in the upstream team, and that's my new rescue pup. Her name's Rue. She came from Taiwan like 2 weeks ago. So I just wanted to put her up there because I think she's really cute.
All right, so my name is Mishra. I work for the Office of CTO at HashiCorp. I mostly focus on developer advocacy. I also contribute to a few CNCF projects, Helm, and some of the secret CSI driver stuff. I'm also one of the provider maintainer for the Virtual Kubelet Nomad provider.
Cool. So Virtual Kubelet, this is our fancy logo. We did a little, we basically voted on GitHub for our logo. Maybe we'll make a new one day. I don't know. That's what happened. So a little bit of history. We open sourced it in 2017. This project actually started out a little bit before that as something called the ACA Connector, and it was just for Microsoft. We realized that this was probably we could solve a lot more problems by making it pluggable and making an open interface so anyone could create providers for Virtual Kubelet. And that's exactly what we did at KubeCon Austin 2 years ago. So I think, yeah, 2017, December is when we ended up releasing it. We're also in the CNCF as a sandbox project. So this happened about, I don't know, 6 to 8 months ago. We're really excited to be part of the CNCF. There's a lot of support that we get from them. And then we also get to come here and do these fun talks with you guys. So a little bit more history. The ACA Connector was the first version of Virtual Kubelet. It was actually written in TypeScript. It was Brendan Burns' baby pet project. We revamped everything with a bunch of people at Microsoft, a bunch of different teams in Microsoft, and we actually tried to create this culture of open source kind of just within our company. So you know Microsoft is huge, and we kind of stay within our own realm of teams. But what Virtual Kubelet allowed us to do is actually reach out to CDAs and other teams within Microsoft to help us build this. So that was really cool. I'm part of product, so it was awesome to see that happen. But then past that, it's awesome to see that continue on. And now we have a huge community past Microsoft. Actually, we have a couple people in Microsoft working on this, but really it's the providers that are pushing this through and everyone else. And we're 1.0, so we went 1.0. We're going 1.0 this week. What that means for you guys is that it is stable. We're stabilizing the interface, so we won't change much in the interface without telling you, basically. And that's for our users. So now users can be sure and they can feel confident that our core interface is stable. Now, each provider isn't at maybe a 1.0 level yet. So that's different. Depending on what provider you're using, if you're using Microsoft's, we are GA. But if you're using Fargate, for example, they're probably still in preview or other ones. So you have to look at which provider you're using with Virtual Kubelet. But you can be certain that core has stabilized. And we've also done a lot of work around governance. So we've figured out how our relationship works with providers. We've figured out who our core maintainers are. We have a process for core maintainers becoming core maintainers and a process for voting and all of that. So if you ever want to be a provider maintainer or if you want to be one of us, a core maintainer, please reach out and we can get you sorted.
All right, so that was a bit of a background on kind of the project where it is now. We are 1.0, which is super nice. Now we'll dive into some of the kind of the intro level stuff, like what Virtual Kubelet is, what it stands for, maybe talk about the providers a little bit. So in order to understand that, I want to do a quick kind of an intro of the Kubernetes architecture. Who here knows Kubernetes architecture inside out? Okay, there's a decent amount of people. Great. I was going to call someone up on stage and they can talk about it. But no, I won't do that. I won't put you on the spot. So yeah, this is probably the quickest architecture overview that you've heard for Kubernetes. It's going to be super quick because it's not relevant. Everything is not relevant in this talk. So yeah, so we talk about kind of the API server, the Kubernetes API server that's responsible for kind of storing and creating and retrieving API objects. These objects might be pods, these objects might be deployments or services or any object, any CRD. You'll store that using the API server, and that's what the users use, and that's what other Kubernetes components inside Kubernetes use as well. Then you have the kind of the scheduler, which is very much what the name is. It's a scheduler. It maps a set of workload to a set of resources. So in a cluster, you might have 100 CPUs, 200 gigs of RAM or something. The scheduler actually maps that maps a workload to a set of resources, which might be a node. And then you have the controller manager, which is responsible for kind of the control loops in the cluster to keep a certain set of controllers, a certain set of actions happening during the course of the kind of the cluster scheduler. And then there's the actual stateful component, which is etcd, which is the kind of the main database where everything is stored. So the API server interacts with etcd and stores and kind of helps retrieve some of these objects. And then on the other side, we have the nodes. The nodes are running something called the kubelet. And this is where we'll kind of zone into the kind of the kubelet and where virtual kubelet kind of fits in. So kubelet is responsible for a lot of different things. I think Ria will go into the kind of the depth of like what all it does. It does a lot of different things. But it's basically responsible for registering a node. So when a node comes up, the kubelet process starts. It fingerprints the node. It figures out, OK, you have 2 CPUs, this much RAM. Let me register you to the Kubernetes cluster. And it does that for you. And then there's other components like the proxy. We won't go into it. And you might also be running things like a daemon, like a Docker daemon or something on the node, which the kubelet also fingerprints and registers with the Kubernetes API. Now we'll zone in into zoom in into the kubelet portion. So as I said, the kubelet is the one that does a lot of different things. Some of these things might be like making sure a certain set of pods are running on the node, making sure certain volumes are being mounted to a certain pod, and so on. So virtual kubelet basically registers itself like a kubelet. So it basically behaves like a node almost. It is like a node. And then it basically implements a series of functions that the kubelet implements, and then it's basically a fake node in a Kubernetes cluster. And to what it is, really is just a program that you can run inside the cluster, outside the cluster. If you have access to the Kubernetes API outside the cluster, you can run it outside the cluster, and then register itself. And then the API server says, oh, you're a node. It just registered it. It registers the virtual kubelet just like any other node. But behind it can be a lot of different things, and you'll kind of slowly find out what those things are. All right.
OK, so when we started Virtual Kubelet, we had to look into what a node was. And this is kind of what we figured out. A node is a static size. You have to figure out how many pods have to go into a node. It has a standard capacity. There are things that the pods get from the node inherently. And then it's also a single fault domain. So that was also a consideration to make. If the node goes down, everything on that node will go down. Kubernetes will try and reschedule. But if you don't have enough nodes in your cluster, the node is the single, it is the baseline for all of your workloads. And this is what the control loops look like. So we have asynchronous control loops, we have synchronous control loops. And this was something, an early design of what we had for Virtual Kubelet. So we were like, we need to create all of these control loops to actually be conformant to what a node is in Kubernetes. We haven't actually gone through the conformance testing in Kubernetes to figure out if we're a node. I don't know if we really need to, because customers aren't really asking us for it. But what's important to note is that we started over here. So we started with getting container logs. We started with getting images and deleting them, and then also starting the container itself. So what Virtual Kubelet allowed us to do was basically extend Kubernetes, extend those APIs to a different service. And we'll go through some what that means in a second, too. So Virtual Kubelet basically is a concept of pods and nodes in the abstract. We have this concept of an abstract node when you install Virtual Kubelet into your cluster. So you'll have a bunch of nodes, and then you'll have this kind of fake node. It doesn't actually have boundaries for capacity. It doesn't have boundaries for CPU or memory or networking or anything like that. It's literally a string that we're passing through to Kubernetes. And we're like, this is a node, register it like a node. Now, the fun stuff happens when you actually start to create pods. So when you create a pod and you schedule it to that node, that's when we do the work of reaching out to a different API, whether it's an API in Amazon, an API in Microsoft, an API at Domino's, that's a pizza place. And then that API will basically take that request and process it in the way that it's supposed to process it. So it'll create a pod in Kubernetes, but what it's doing in the back end could be creating a pod in a different data center, in a different cloud possibly. Or it could be registering that pod and ordering you a pizza from Domino's. There's a lot of different things you can do with Virtual Kubelet. It doesn't just have to be the concept of creating containers. It can do a lot of other things. So why Virtual Kubelet? So yeah, it's flexible. It's a flexible abstraction. If you have an idea for what you want to do in Kubernetes and Kubernetes isn't supported today, you could possibly make it happen with Virtual Kubelet. And we have a lot of different use cases. So we have this really cool use case for bursting and on-demand capacity. For example, if you have a bunch of, this is an example I like to give all the time, but basically, if there is a hurricane, say in Barcelona, and I'm a meter reading company, and I'm trying to read all the meters in all these different buildings, I'm probably going to need more capacity in that instant because it's a random event that just happened. I wasn't prepared for it. So you have to ramp up your capacity. Virtual Kubelet allows you to not have to have that capacity directly in your cluster. You can basically ask for it on demand depending on the service that's backing you up, which is pretty cool. And then we have some other interesting use cases like high availability. So you can put a Virtual Kubelet in different regions, and then you suddenly have high availability within your cluster. Networking might not work, but we can work through that. IoT Edge use cases and alternate kubelets. So you can have a Virtual Kubelet that spins out to Windows or a different OS, and one that spins out to Linux.
All right, so where is the magic, right? This is a lot of text here, right? And so where does it get interesting for a user or for a developer who's interested in using Virtual Kubelet, right? So the provider interface is basically where it gets interesting. So the provider interface itself kind of allows you to use Virtual Kubelet framework that's written, that's open source, that's the kind of the big project. So the provider interface has a lot of different functions. These are some of the functions that you might see: the create function, the update function, the delete function, the get pod function. You might want to satisfy most of them, but there's some functions that you can't satisfy given the target platform. For example, the Domino's pizza case, I don't know, there might be some functions that you can't support in that one use case. But the idea here is to kind of, once you satisfy this interface, you're able to use the Virtual Kubelet framework and then be able to schedule pods, do things based on a create or a delete event. So the definition itself of the provider is actually pretty straightforward. You need to provide the backend plumbing necessary to support a provider. For example, in the Domino's pizza case, you will need to write the code that actually calls the Domino's API, orders a pizza, waits on the status of the pizza or something, and then reports back things and so on. So that plumbing is actually written in the provider itself, and it's behind the interface basically. And then also you need to confirm with the current Virtual Kubelet API to be an official provider. There's other list of things that we kind of now have as part of a last in-person meeting that we did, which kind of gives you a good guideline of what other things that you would need to kind of submit an official provider, basically. And then you do not have access to the Kubernetes API server using Virtual Kubelet. So for example, you want to get secrets and do things like mount volumes. So currently, we don't provide that via the API server. So we won't expose the API server to you. You'll have to go out of band and do those things so yourself using your own K8s client, basically. Yeah. That's you guys.
This is me. Cool. So yeah, we have a bunch of providers in Virtual Kubelet. You can pick and choose which ones you want to use and install them in your own cluster. But in this case, today you can spin out to ACI, Azure Container Instances. You can spin out to AWS Fargate, and then Nomad, Domino's, Mesos, IoT Edge, and a bunch of others that I have on this slide. So we also have Huawei, we have Alibaba, Azure Batch, and CRI and stuff like that. So if you want to use any of these in any kind of cluster, so if you're in Google or Amazon, you can pick up any of these, or if you're in on-prem, and now you can spin out to these kinds of clouds, which is pretty cool. Okay, so the IoT Edge use case. Might be self-explanatory, but it might not be. But basically, you can mask Virtual Kubelet and make it look like a node. For example, if you wanted to turn on a light in this room, you could spin out a node, it would start, and then it would turn on a light. If you wanted to update the pod, you could update it with a new YAML, and then it would maybe change the light color, for example. So that's an example of how you could use IoT Edge. You can actually go into your physical environment, or you could spin out to your microwave. We had some people talking about how they wanted to use kind of scenarios like this to spin out to satellites. So they wanted to connect satellites to their Kubernetes clusters, and they wanted each node to look like a satellite. You could kind of do that, actually, and then you have one common API to work from instead of working from something else, if you're familiar with Kubernetes. And this is the Microsoft use case. So I'm from Microsoft, so I'm going to plug that one too. So the virtual node, we call it virtual node. It's GA today in Azure. But basically, you can have a bunch of VMs in your cluster, but if you need on-demand capacity or compute, or you want to burst out, you can use ACI as that kind of safety mechanism to burst out. It's also like you pay per second and that sort of stuff. So that's also a cool use case. I know Amazon has a similar one. Alibaba actually also has a similar one. So a lot of us have this similar use case of just bursting out into compute. The way that you would use Virtual Kubelet and actually schedule out to it is through these tolerations. So we've tainted Virtual Kubelet, and what that means is we basically have a lock on it. You can't schedule anything to this node, and we've done this because we think it makes it easier for customers, because you don't want to randomly get scheduled out to something that you don't know. So basically, you have a key, and every key is different depending on the provider. And as long as you put this in your spec, you're allowed to get scheduled out to Virtual Kubelet. We also can use these affinity rules, anti-affinity and affinity rules, to say that we prefer different nodes in our cluster. So in this case, we're actually preferring the nodes, the actual nodes in our cluster versus Virtual Kubelet. So this will allow you to fill up the nodes and then burst out into VK if you need to. Cool. OK. So this demo it's not live. I'm not doing it live because Wi-Fi is crazy everywhere. But we did a workshop yesterday, and basically a lot of people were able to deploy this demo. It's in Azure Samples, but it's all running with Kubernetes and then Virtual Kubelet in the background. So we have this front end. It's just a store. So it's like a power tool store, basically. And then you can buy a power tool. You can buy some home gardening stuff. I kill every plant ever, so I'd probably go to the garden center and ask for a gardener. I don't know. OK, this is the cool part. So we have this Grafana dashboard. And what we've done here is we've used Virtual Kubelet to be able to burst out into it. So we have two pods running in our cluster by ourselves. And then we have 19 pods running in ACI. So what we've done is we've spun out a bunch of load to the cluster itself and a bunch of requests. And we're scaling on custom metrics. So what that means is we're using requests per second, and that's all of the requests per second to the entire cluster. And we're calculating it per pod. And once we get to 10 requests, we're scaling out another pod. So these are all Kubernetes concepts that we're using to autoscale into ACI, which is pretty nice. You can also see our response time. So this is how you know it's working. So our response time went up, so it was really slow to get back to people because we didn't have enough capacity in our cluster. We jumped back down when we got a bunch of pods in our cluster ramped up, and they were actually contributing to getting all those requests, and those were the pods in ACI. So then our response time jumped back down. So that's what you want to see. Cool.
Yeah, now we have another demo, which is live. So hopefully the demo gods are with us today. Otherwise, we will stay in this room until I fix the demo, and then we'll leave. So, all right. So here I have a Kubernetes cluster. So I do get nodes. Hopefully, I do have it still. Yes, I do have a Kubernetes cluster of 2 nodes, right? We have 2 worker pools. This is actually running on DigitalOcean's managed service. Shout out to them. I just wanted to use DO someday or the other. This is one of my bucket list things. So I did that. So we have the 2-node cluster, super scalable, of course, because 2 nodes are in there. We can schedule whatever we want on it. So let's schedule something on it. So here I have a simple Nginx pod. So I'll open this up. Here I have a simple Nginx pod. There's no trickery here. There's no taints as well, which Ria talked about on purpose. I just wanted to keep things super simple. So now I'll just run this pod. So I'll just say kubectl apply Nginx, and hopefully this works. And then do kubectl get pods. It's pending, which is not a good thing, and it's running now, which is great. So I'm just, by the way, this is not the demo. I'm just making sure the cluster works. Is that okay? Yeah, that's okay. So yeah, so you all were like, why is he showing us how to use Kubernetes? We know that already. So okay, so that was just to check the cluster. Oh, okay.
Everyone's speaker sessions.
Thank you. Okay.
After
okay,
this.
So that was great. Okay, so the cluster works, and that's it. That's all I know. I don't have more stuff. Okay, so now let's inspect one of the nodes, right? So let's do a describe node on one of the worker pools. This is one of the nodes. Let me actually grab one of the real nodes here. kubectl get nodes, and then let's do kubectl describe node, and then the node name. So here you'll notice like the node itself has some stuff running on here. So this is all DigitalOcean's by default. They run Cilium and things like that. You'll see some of the capacity things here, like how much CPU is allocated and allocatable. And then we have a few of the events and stuff. So here you see like we have about 20 CPUs available, and then 100 gigs of memory. I think this is the wrong node. I guess I'm definitely listing the wrong node. Hold on a second here. Let me list this one. Yeah, so this one's this kind of the smaller node here. So it has like one go scroll up here. Where is the thing? So much YAML. Oh, hold on. Where is the capacity? Yeah, right here. Okay, so here's the capacity. So there's the one CPU. So I apologize. Okay, one CPU and the storage and the memory and these many pods, right? So that's kind of the gist of it. So now what we'll do is something interesting. We'll actually make one of these nodes unavailable in Kubernetes. And I'll show you, and I'll talk about why we're doing that. So let's do kubectl get nodes. So who's used the cordon command in Kubernetes? That allows you to kind of just mark it. Okay, sweet. So kubectl cordon. And what this does is basically makes one of the nodes unschedulable. So this scheduling is disabled on one of the nodes. So now if I create another pod, it won't land on this one, but instead will land on the other node. So now, what do you think would happen if I actually schedule a lot of workload? This is just a cluster with 2 nodes and like 1 CPU and bunch of memory. So let's see, I'll run Nginx pods many, which has many Nginx pods, and I'm not using deployments on purpose. I just want to show you the simplest form of things, because this has like, I don't know how many, 18 Nginx pods. So let's schedule these, right? So kubectl apply, and then do this. All right, so we scheduled 8, and now we do get pods. And they should only go in pending. Well, they're all running. I wonder why they're running. So now, actually, what has happened here is like what I tricked you in thinking that the other node was like kind of part of the DigitalOcean managed service, but the other node was actually a virtual kubelet, right? And it's masking another scheduler. So where are these workloads actually running? If we switch, and hopefully this doesn't, okay, there we go. One second. No one saw that. Okay, here we go. So they're actually running on Nomad, so on a completely different scheduler. But you're still using the same kind of definition that you see on the Kubernetes side. So if I open the YAML file again, which we love looking at these YAML files. Here we go. So here, it's like there's nothing different about this YAML file to kind of schedule it here. I'm not using any tolerances or anything, just to keep things simple. So just to show you this is real, like it's actually, I'm not faking this. Let me just delete those pods and switch to the thing, and hopefully you'll see them disappear as we hit delete on the other end. So it's a pretty clean interface. Thank you. Thank you. So it's actually a pretty clean interface, and I think this is one of the things that I felt like was is interesting because you're using two schedulers, right? Like this is, I'm just showing you like the extensibility of VK. It's not, in many cases, this does not make sense. So do not do this in production all the time. But for a particular use case, it might make sense. If you want to use Nomad for batch scheduling, then you can still use the same common interface to interact with it. If you're used to Kubernetes and you want to use that, you can do that too. So it's super flexible. And I think one of the things I want to point out is like just my personal experience of building the provider. It literally took me, like, I think I spent, it was my Christmas project, so I spent like the 4 or 5 hours at night after we had dinner to work on this, and I was able to get to kind of, from 0 to something. And then I spent a few more hours kind of going through some of the docs and finished the provider. So it's a fairly easy thing to kind of get started. So I think it's very easy to write a provider is what I'm trying to get to. So we encourage you to write many providers. Okay, I'll switch back to the slides. Oh, did I say, okay, sorry, I apologize, from current slide. Oh, no. Where were we? I think we are here. Okay, so yeah, so what has happened here in the background, I'll quickly give you an overview of what exactly you saw. So once we scheduled those many pods, those all ended up in the virtual kubelet node, which is this one here. And then it goes through, and then the actual provider interacts with the Nomad API and says, hey, like I'm going to translate the pod spec to a Nomad task group, which is the equivalent of a pod in Nomad, not in the networking use case, but just as an idea. So in Nomad, we have task groups, which are like a set of co-located containers. So in that case, you see that gets translated into a task group. Then Nomad scheduler kicks in again, schedules it into a Nomad client, and that starts the process. So that's kind of the flow of events for those of you who are interested. So that was the cool demo. I'm not saying your demo wasn't cool. I apologize. But that was an interesting demo. And thank you for coming to our talk. And there's another deep dive session that Jeremy and Ria, they're doing, I think, on Wednesday. So please go and watch that. That's a deeper dive into all the internals and everything else that you want to know about Virtual Kubelet. Hopefully this serves as a good starting point to get excited about Virtual Kubelet. Thank you.
Thank you.